I want to show you, I've got some solid air here, and I want to, so in here I have some solid air. You think that the air that you breathe out, take a nice deep breath. Now breathe out. Okay, do you think that the air that you breathed out has molecules that are close together or far apart? Far apart. And that makes sense because they're a gas, right? And we can walk through them. It's not like hard to walk through. Molecules are pretty far apart in a gas. Okay, what gas did you just breathe out? CO2. CO2. You've breathed out a lot of nitrogen and other things, but CO2 is the one that we're going to talk about. So take a nice deep breath. Now, I need some people to be my CO2 molecules. Who's willing to come up here and help me out? CO2 molecule. You're going to be over here, and your head is going to be carbon, and your fists are going to be oxygen, and they're going to be stuck together like this. So do that, okay? You do the same thing like that and that. We need you far apart because you're a gas. You've just been breathed out. Now, just to point out, this is called a molecule, carbon dioxide, but each of these is an atom, right? Each carbon atom, oxygen atom. When they're bonded together, you call it a molecule. Okay, so we got 4 molecules of carbon dioxide, and we've just been breathed out. We've been breathed out of a warm body, which means we're wiggling pretty quickly, and we bounce off of each other if we hit each other. So we're far apart, and boing, and we're bouncing off. You don't have to do it, but you just get the point. Now, what if we wanted to make solid air? What would we need to do? Yeah, so how would we do that? Well, we need to... we need to get us really cold. So we'll start moving slower and slower. Now, if we're really slow and we hit each other, we sort of stick together. Come on in and stick to me. There you go. Come on in and stick. Now we're just wiggling in place. We're really slow. But now, what if you wanted to turn us back into a gas? What would we need to do? Heat it up, and we wiggle really fast and jump back out into gaseous form. Okay, give these folks a hand. I'm going to actually do this right now. So I have here some solid air, and who knows, some of this might have actually been breathed out by you. You never know. That's right. So the reason why I'm wearing gloves is because the dry ice, and that's what it is very, very cold. It's something on the order of negative 180 degrees Fahrenheit, negative 80 degrees Celsius, something like that. Okay, so here is what happens when I warm it up with this warm water. Okay, and you see it bubbling. See the chunk of it bubbling? Now, there's a little soap in that cup, so it looks like an afro. Yeah, it looks like a cupcake. Okay, I'm going to set that down for a second in there so we don't make a mess. Now, I want to point out a couple of things about dry ice before I do the actual thing I'm going to do with it. Because people die every year from dry ice, and I don't want you to be those people. First of all, it will continue to make bubbles, and in this case, you can see the bubbles are continuing here. It's going to continue to make bubbles on and on and on and on, even if it had a lid. And it would create a great deal of pressure, enough pressure that if it had a lid on it, that thing would explode. Most things would explode eventually if you just put dry ice in them. And people do that, and they're like, oh, it'll be really cool. And then they get like essentially a bomb that sends out little bits of shrapnel of whatever it was that it was in. So you really never want it to be in something that is enclosed. It's seriously really dangerous. People get blinded, especially. Okay, the other thing that happens is that if you're in a very small enclosed space for a long time with a lot of dry ice, it will tend to push the oxygen out of that space, and the space is going to fill up with carbon dioxide. What's the problem with that?
No, you can't breathe.
Yeah, you can't breathe, and you need oxygen to burn your food and to make your brain function. So you don't want to, like even when I travel with dry ice in my car, I always leave the window cracked just to be safe. That's probably a little bit of overkill, but it is important to know those two things, and also not to touch it with your bare hands. Because it's so cold, it'll give you frostbite. Now, I'm going to put it in here, and I know you're saying, wait a minute, Jeff, I thought you said don't put it in something that's enclosed, but I want you to notice that this thing is not entirely enclosed. right? So it's open on this end, and it's also open on this end. Even when I cap it here, it'll still be open on this end. Okay, so I'm going to get this set up here, and I'll show you how it'll work. Let's get my gloves back. So I'm going to ask you to think about what might happen when I put dry ice in the bottom there and warm it up by adding warm water. What's going to happen when I cap the bottom? Works a little better with smaller pieces, gives me a little more surface area. Okay, and so I'm going to add some, oh, I have to get one more thing here, hang on, for my demo. Okay, so I'm going to add some warm water here. What's going to happen? It's going to start bubbling, okay, and I'm going to cap it off. Now what's going to happen? Going to go out the other end, excellent. Okay, now I'm going to add a little bit of water to a cup and some soap. We'll see if we can catch any of that in a bubble. Okay, now, in the back, in the gray, come on up here. Yeah, yeah. What I want you to do is try to catch this. So come stand behind me here. See, yeah, okay. See if you can catch one. It keeps breaking. Try putting your sleeves over your hands, like so, and try to catch it in those. It's actually really hard to catch it. Only certain materials work. I'm still trying to learn how to do this. Oh, try moving your hand down a little as it comes. Oh. What's inside this bubble? What kind of, oh, nice, nice, nice. You had it, all right, all right. So what's inside the gas? What's that? CO2, carbon dioxide, that's jumped back out into vapor form. It's jumped back out because it got warmed up. The fog is actually water vapor. CO2 is invisible. Okay, give my friend a hand. Thank you.